Statistics can be fascinating, a combination of math and logic and philosophy that provides great insights. It can also be a little intimidating, or at least overwhelming. If that's the case for you, I hope the way I approach it in this class makes it a little less stressful. Right now, I just want to introduce a few basic concepts so you know why statistics is part of research and what's important. As we look at articles, we'll learn how APA-style formatting helps make the statistical results a little less overwhelming. When we work with statistics later in the semester, we'll focus on what they tell us and how to use a statistical analysis program called SPSS. In other words, you won't need to calculate statistics. There are two broad categories of statistics, descriptive and inferential. The difference goes back to what we learned about samples and populations. Descriptive statistics help us understand the sample. Inferential uses information from the sample to draw conclusions about the population. Descriptive statistics include measures of central tendency and measures of frequency. For example, the descriptive statistics for our sample of M&Ms might include the frequency for each color and the average or the mean number of each color. I hope you find that the descriptive statistics are pretty straightforward. The one thing that can be a little tricky is that we use different statistics depending on whether the variable is numeric or categorical. That tends to make sense when we think about it, though. Computing an average for age is meaningful. Assigning a numeric value for different sexes and then computing an average, not so meaningful. Inferential analysis uses information from the sample to draw conclusions about the population. For example, they would use information from a bag of M&Ms to draw conclusions about how the different colors are represented in the entire population of M&Ms. Inferential statistics include a wide range of tests, but they are all based on probability, the likelihood a finding is due to chance rather than being due to a systematic variation in our data. There are two important ideas we need to understand about that: statistical significance and effect size. Statistical significance, also referred to as the p-value, is the likelihood the findings are due to chance. What's the likelihood that our findings represent a systematic and stable pattern in the population rather than happenstance, or the way the stars were aligned that day, or you get the idea. We typically consider a finding to be meaningful if the likelihood of it happening due to chance is 5% or less. In statistical jargon, that's described as a p-value of 0.05 or less. When the p-value is 0.05 or less, we say the findings are significant and interpret them as meaningful, meaning we have identified a meaningful pattern in the variables. The tricky thing is that we can have statistically significant results that don't really mean anything. In the language of statistics, they have a low effect size. Here's an analogy that might help. With many scratch-off lottery tickets, you scratch at a certain place to reveal your numbers. Then you scratch another place to see if any of the other numbers match your numbers, or if you have the special symbol that means you win 10 times the prize value. So you could scratch off all the numbers and not match anything. That'd be like having a p-value greater than 0.05. You could also scratch and find a match. I'm getting a little excited, right? It's like having a p-value of 0.05 or less. Quick, scratch off the prize. Oh, it's a free ticket. That'd be like having a low effect size. It's something, but it's not really a winning. If we had the special symbol and won 10 free tickets, that might be like a little higher effect size. At least we won something more than the money we spent. What we're really hoping for, though, is the special symbol and a large cash prize. That's like having a high effect size. These four concepts, descriptive statistics, inferential statistics, statistical significance, and the effect size, are just a starting point for understanding statistics. They're a good starting point. Understanding the difference between descriptive statistics and inferential statistics reminds us that our purpose is to understand a larger group, and those with expert knowledge in statistics know how to use the smaller group to understand a larger group. Understanding what it means when a result is statistically significant reminds us that we're drawing conclusions based on probability, or the mathematical likelihood of something happening. Finally, understanding effect size helps us understand whether the finding is really meaningful. Taken together, this helps us understand the goals of statistical analysis, the underlying logic, and how we find meaning in the findings.